All right, so I had suggested to pause the video, and I'm recording on my iPad, and apparently it stopped the video. So this is the second video, so you're not haven't done anything wrong. But let me sketch negative 2.01, which is way out here somewhere. I'm interested in that area. And the area that you should be getting for negative 2.01 is 0.0222. 0.0222 is that area, a really small area. Y'all, as those z-scores get further and further out, the area in the tail gets small, small, small. And then to the left of positive 0.73, positive 0.73. Still looking at the area to the left. Positive 0.73 area is 0.7673. Okay? If you can find the areas to the left, y'all, you can find any area that I give you. All right, and feel free to pause as we work and go back and look at some additional ones. But let's change the game a little bit. Still finding areas ultimately, but now I want the area to the right. Let's find the area to the right of positive 1.96. Positive 1.96 is way out here, but this time I'm interested in this area. My chart doesn't give me the areas to the right. I've got to find a way to do that. But I do know the area to the left. This is what I'll call the red area. You can see that on your screen. The area to the left of 1.96 is 0.9750. Excuse me. I'm not interested in that portion. I'm interested in this portion, which is going to be the difference between 1 and that value, which is 0.025 for that solution. So again, my chart is the chart. It gives me the areas to the left. I've got to find some ways to do that. I'll talk about another way with that in just a second, maybe a little bit easier. But let's find the area to the right of negative 0.75. Find the area to the right of negative 0.75. And again, I'm interested in this region. So I can look up the area to the left, which is what I've been doing, negative 0.75. That area is 0.2266. And I'm going to take that away from 1. 1 minus 0.2266. And that area in question is 7734. Okay, so we've done areas to the left, we've done areas to the right, but let me show you something else about those areas to the right. Remember what I told you to start with is that this curve is symmetrical. So the area to the right of positive 1.96 is exactly the same as the area to the left of negative 1.96. So I don't have to do any subtraction there. And if I look up that area, I get the same answer. I just get it a little bit faster. And some people like that idea. That's using symmetry to do the same thing. Listen, you can always subtract, but you can also work yourself to death there. Symmetry works pretty nice. The same thing here, the area to the right of negative 0.75 is the same as the area to the left of positive 0.75. So just take a minute and find that on your chart and verify that. And 0.7734, we find it directly. Okay? So areas to the left, areas to the right, we're able to find, oh sorry, my picture's off the screen, but there's the picture to the left of 0.75 and its corresponding area. So what I'm ultimately interested in is all sorts of situations. So let's look at some other ones. Number 7, let's find the area between z equal to 1 and z equal to 2.10. Find the area between z equal to 1 and z equal to 2.10. Again, let me sketch that picture. So here is 1, and out here somewhere to the right of that is 2.10. Ultimately, I'm interested in this region, okay? Again, my chart is the chart. All it gives me is the areas to the left of each of those z-scores. So I've got to work with that. So let me find the area to the left of positive 1.00. And my chart says that that region is 0.8413. Let me also find the area to the left of 2.10, which is 0.9821. Neither of those are my answers, and you know on a multiple choice test, those will both be choices there. What I'm interested in is the difference of those. So 0.9821 minus 0.8413, and I'm getting an answer of 0.1408 for that region. As long as it's between, I think almost without exception, you'll always be able to subtract those areas. Let's try another one. Number 8, let's find the area between z equal to negative 0.15 and z equal to positive 0.96. Okay, again, it's a between situation. So here is negative 0.15. Here is positive 0.96, and I'm interested in this region. So let me look up each of these areas. Let me look up the area to the left of negative 0.15. Negative 0.15, that area is 0.4404. Let me also look up the area to the left of positive 0.96. Positive 0.96 is 0.8315. And again, the difference in those is going to be the answer to my problem, which is 0.3911. All right, so we're able to find the areas to the left, areas to the right, areas between, and all of that has got to work together to answer some questions. It all boils down to, everything we're going to do boils down to reading the chart. So, in chapter 7, you've got some word problems to ultimately look at. Your first homework is going to be reading the chart, answering these type of questions. In chapter 7, though, what we're doing is looking at some word problems. So, let me go back to our z-score formula. You have 2 of those. Let me make that be an S. I apologize for that. We have essentially 2 z-score formulas, which they're conceptually the same. You'll probably see this one in your textbook, but it stands for the raw score minus the mean divided by standard deviation. So if I want to know, let's say I gave a test and the mean of the test was 78, a standard deviation was 5.1, I want to know how many people scored above a 62? What percent? Really not how many, but what percent? That's a better question. All right, so the first thing I would need to do is to calculate a z-score. So there's my z-score formula, my raw score minus the mean divided by standard deviation. So 62 minus 78 divided by 5.1 is a negative 3.13. And again, I'm just making up a problem, so that's going to be a little bit goofy on your chart, but it's okay. So I want to know what percent, how many people are above negative 3.13 is actually the question. Y'all, negative 3.13 is way out here somewhere, and I'm interested in this region. But again, to answer that, what I'm going to do is I'm going to look at the area not to the right of negative 3.3, but the area to the left of positive 3.13. That region is the same region. It's symmetrical. So if I look up positive 3.13, that region is 0.9991, which means almost 100% of people scored above a 62 on that problem. So that's ultimately where we're going with the Z distribution. So in chapter 7, you're looking at this formula, but it's using the chart. The only thing that's going to change is when you get to chapter 8, and I realize this is a quick version, so you're going to want to go through and work through the homework and ask questions, of course. When we get to chapter 8, we're not comparing one score to everybody, we're comparing the mean of a sample to everybody, which gets much more interesting. One of the things that's tracked at the State Department of Education is test scores per school. So if they find out that Dr. Ross's class, 6th grade reading class, is blowing the roof off the reading test, then they're going to want to know why, right? Because that is probably an unusual event. My group of students is scoring significantly higher than everybody else. So I would compare their average score to everybody else in the state of Mississippi. And the formula that we use to do that is this formula, which stands for the mean of the sample, the mean of the population, the standard deviation of the population, and then finally the number in the sample. But I'll get a Z-score there and find a corresponding area. So just a comment about these two ideas. There may be somebody in our class that has, say, an IQ of 150. That's considered a genius level IQ. That's possible. But it's a real small probability that that's going to happen. But if I have a sample, if I go out there and find a class that has 30 people in it, and their average IQ is 150, that chance goes down even more significantly. So there'll be some problems in chapter 8 where you compare one score and then you compare the mean of a sample, and you'll want to read those carefully. It's not too difficult to make this happen. These probabilities get real off kilter. They get really small really quick, and should. All right, as always, email me with any questions. I'm going to email you and post into Canvas what you're responsible for the rest of the semester. We'll have to omit a couple of things because of the storm, but that's okay. Let's do the normal distribution and the other things that I asked you about. If you still need to meet with me, you're welcome to do that. Just send me an email, let's schedule that. And I'm available this week on Tuesday, Monday, Tuesday, or even Thursday. I can meet with you in Hattiesburg somewhere, perhaps at the Hattiesburg Library or somewhere like that if we can find a convenient spot. But maybe these videos will be sufficient enough. All right, good luck to you.